Okay, good morning, ladies and gentlemen. I'm really pleased to be here at Cardiff City Stadium, and I hear Cardiff City are doing very well today, so this season, so that's good to hear. So that's a very positive story. In terms of Green IT, and what we're going to do for the next few hours is we're going to go through all the basics, the fundamentals, some of the key issues, and I'm going to throw a lot of issues on the table. And the aim of that is that everyone here today should go away with something. So some idea, something you can take back to your organisation to deliver savings. As Lee said, please interrupt. Please, I'll ask for discussion as we go through. Despite the fact that we're being filmed, the cameras are not going to pan in on you. Okay, so you're most welcome to ask questions. And I hope we'll learn more around the tables. I mean, clearly, a lot of you have got quite a bit of experience. I know you're all purporting to be novices, but actually, in reality, there's a lot of knowledge out there. So hopefully, we will have workshop exercises we go through, and you can share ideas, and we can share and get some ideas from yourselves as the audience today. If you look at your energy consumption in your organisation, it's quite surprising. It will probably be at least 15% of your electricity bill. You need to monitor it, and we'll perhaps talk about that a little bit later. But at least 15%, and often up to 20–25% of a commercial organisation's electricity will go to ICT. So it is a very significant part of your bill and a very significant part of your carbon footprint. In addition to that, you've got the air conditioning costs that are associated with that. If you have got an air-conditioned building, you can probably double that, and we'll talk about that a little bit later on. And obviously ICT is increasing all the time. The amount we use it, the equipment we're bringing in is increasing. Are you getting rid of rationalising redundant equipment and getting it out of the office, or is it just slowly growing? So there's lots of simple things that we can do. And this is why the Carbon Trust want everyone to try and address this issue and why it's so important to us. What are the drivers for green ICT? Well, firstly, energy costs are rising. They're escalating at a rapid rate, and we'll have a bit of a look at that. Many of you, the larger organisations, will be reporting your carbon emissions in the Carbon Reduction Commitment Energy Efficiency Scheme. That is put you into carbon trading, and has probably cost you a lot of money over the summer in terms of buying carbon. You've also got mandatory carbon reporting coming in next April for the FTSE main index. So you've got 1,000+ companies reporting on their carbon footprint as a mandatory requirement. And of course, these things are coming out to all businesses in the longer term. So we should all be in carbon trading as time goes on. So just think about where you are with regard to that. The comfort in our offices, environmental comfort. Are people overheating in the summer months? IT is a significant load within our building. And again, controlling that will make your office much more comfortable. There are a lot of codes of conduct, EU codes of conduct, that are coming out. Again, they are voluntary initiatives to get you to look at this, but do perhaps log in and have a look at some of those and see what they're saying. It would be great if more of us could respond to those. Procurement, the government buying agencies, the government standards, have got standards for procurement of green IT products. You, as consumers, need to push the IT industry. The IT industry are also responding to this with their own standards and vastly improving the energy efficiency of their products over the last decade, and we need to make as much use of that as possible. There are some surveys. Greenpeace, for example, have done a survey of data centres. How dirty is your data? And I'll talk a little bit about that. Virtualization can reduce the capital costs that you're spending on IT by perhaps going to virtualized computers, so one computer becomes equivalent of 10 or 20. Thin clients are much cheaper, much longer life, less obsolescence, so lots of things are improving there. People are moving away from PCs to laptops, so people are more flexible, more mobile. People like that. They can take their work home with them much more easier. Things are changing very rapidly over the last sort of 5 years. So all of these are the key drivers that are driving this. Let's have a look at volatile energy costs. This is a graph that shows over a number of years the wholesale price of gas. And 2008 is the green line at the top here. And you can see the peak with Hurricane Katrina. And I think that you can see how much, this is pre-recession of course, with us all before the financial crisis. And across the globe, we are trying to move very quickly, capitalise India, China, using greater quantities of oil. The last 2 years, though, in the midst of recession, the light blue line and this year the purple line, ending here at the moment, are remarkably high when you consider that we're in the midst of a global recession. And you've got to think about this when we come out of the global recession, what is going to happen to energy costs and energy prices? And you need at home and in your organisations to try and mitigate that risk as much as possible. In terms of carbon footprint reporting, many of you are in the carbon reduction commitment. It's interesting, today we'll have an announcement as to the future of the carbon reduction commitment, so it's very pertinent at the moment with budget statements later on from the government. You've got the Carbon Disclosure Project for major companies, multinationals across the world, disclosing what their carbon footprint is, and this is very important for investor-driven, and makes a significant difference to that. The government have gone one step further. The UK government are bringing in mandatory carbon reporting, the first across the globe to do this in the London Stock Exchange main market, and carbon trading will expand. So do think about your position of that in the future. IT is also a component of heat gains to our offices, and quite frankly, we are not going to move greatly on climate change unless we get rid of air conditioning. If we have all our offices air conditioned, all our factories air conditioned, it's not a clever thing to do. So we must avoid air conditioning like the plague. And in order to do that successfully, we need to reduce our heat gains to less than 40 watts per meter squared within our buildings. And our heat gains come from the lighting, they come from the IT loads, they come from us. We each generate about 100 watts a person, so if we're in 10 meters squared of office, that's 10 watts per meter squared from ourselves. Solar gains through the windows are very significant. We need to cut that out, and we need to mitigate with controls the operation of all of our plant. And if we do that well, we can create a comfortable environment with natural or forced ventilation without air conditioning. That's got to be the solution within our buildings, and that's how we're increasingly designing our buildings. IT is a very significant element of that. And if you look at a simple overheating office using old-fashioned technology, our lighting was up at 20 watts per meter squared. Our IT, we used to design it at 250 watts per person, 25 watts per meter squared. And your heat gains are twice what's needed, and everywhere is very hot in the summer, or you've got to put in air conditioning. The IT industry have embraced energy efficiency over the last 5 years. IT was not really embracing the carbon agenda over 5 years ago, I don't think. But if you approach your IT managers now, it's in their magazines. Low carbon IT technology is there. It's very much part of their industry now, and that's a sector they're doing a great deal for the climate change issue. Typical office equipment is now down to 50 watts a person in a modern office environment. If you've got laptops or you've got thin clients, you can get to less than that even, but that's the sort of level. So from 25 to 5 watts per meter squared. And if you add that up then on the sort of overall gains, which you try to mitigate the gains, you're down at 28 watts a meter squared, and you can keep the heat gains in hot summer to 3 degrees centigrade or less, and therefore you can create a relatively pleasant environment without freezing cold air being blown at you from the air conditioning plant. So it's a much better operating environment as well as being energy efficient and carbon efficient. So for all of you that have got air conditioning, I think you need to be radically thinking in the future about trying to get rid of it out of your offices. I mean, that's where the money is, and many people have successfully done that already. So let's try to mitigate and get rid of air conditioning. Expensive for capital, expensive for maintenance, and expensive for energy. Some useful government buying standards. There's a website access there. These slides can be distributed or will be distributed to you today, so please don't take too many notes if you don't want to. But the website access there are some good buying standards saying what sort of questions you should be asking for, what sort of energy loads different pieces of equipment can take, what the standby loads are, so some really useful piece of information there. And indeed, the IT sector itself has got their own sector guidance there. The GHG protocol, ICT sector guidance, is something that's been created by the ICT industry to try to get them uniformly to work together to respond to reducing the energy consumption within our equipment. So there is a lot of good work being done on this. The EU Code of Conduct is a voluntary initiative asking all organisations to monitor their energy, and we'll talk about that a bit later, implement carbon-saving technology, and also work to influence the supply chain. So those of you who are in supply chain may find that people are asking you, what are you doing about this? And so just recognise that that's there and is a useful thing to read. And indeed, again, the EU broadband equipment, this is again for suppliers into the market. Broadband is increasing, the amount of use of broadband is increasing hugely. Across Europe, we're expecting that to be 50 terawatt hours a year in the future, and this code of conduct is asking the suppliers to drop that by 50%. And broadband efficiencies of all broadband equipment is being worked on by all of the major companies to achieve that aim, and that will be achieved. So there is some, again, good work going on. It is quite high profile. Greenpeace have done some good work here. This is a piece of work where they've researched data center power consumption, working closely with a number of organizations, and have started to publicize the results of that. And in particular, I think it's working positively to publicize good practice. And you know, these various large companies do come under a little bit of fire at times, but here you've got Google aiming to have 100% of their electricity to their data centers coming from renewable energy. Microsoft plan to be carbon neutral by 2013. Facebook, another major name, have for the first time published their carbon footprint, and they're building a low carbon data center in Sweden, where obviously the weather is a lot colder and they can get a lot of free cooling. So there's some great work being done by some of the major suppliers. Any other drivers that I haven't covered? Any thoughts on drivers for your own organisation? Any other thoughts on that? I think, well, why are you sitting here today? Any drivers that you've got? Anyone want to volunteer something to get things, get the first suggestion? Yes, sir, thank you.
One of the stuff we do with school design is BREEAM compliant, and when we're looking at
Fantastic.
those sort of requirements, IT is a significant part of that, yeah.
Yeah, so BREEAM, getting BREEAM good, very good, or excellent. Not easy to get BREEAM excellent. Got an architect here who's doing that type of work, and you know, ICT is one of the issues he's going to be looking at. And to get BREEAM excellent, you need to cover the ground almost every single element and get as many points as you can. Yeah, absolutely, really good driver. Any other thoughts on that? Okay, let's go on to some of the active carbon reduction you can do. First of all, I'd like to just talk about surveying and auditing and introduce you to some work that's been done in the higher education sector by SUST IT project. This was funded. A lot of work's been done. They do some very, very good work, and this is the website. And the tools that they have developed for the higher education sector are on free release. So register with them and you can use this. In particular, they've got a very good IT carbon footprinting tool for doing a survey and auditing your ICT equipment. They also got specialist information, thick clients against thin client computers, things like that. So there's useful tools here, and they've done some very good work. I just want to cover that because as a simple spreadsheet tool, this is a very straightforward, simple auditing tool for IT, and so I think it's useful for everybody. The tool is a simple Excel spreadsheet and asks you to complete it by two methods. One is to look at all of the items of equipment, you put them into the spreadsheet tool, along with the wattage that each of those take, and that probably comes from the platelet rating or for the specifications, and you multiply that by the hours of operation. And so it's a very, very simple, quick method, and you can get a reasonable, quick audit out very, very fast by doing that. More accurately, you may want to have an electricity meter, and you might want to monitor a laptop, and you might want to monitor it as it works. So this laptop will take about 30 watts as we're actively working. At the moment, it's probably dropping down to more like 20 watts because we're not doing a lot here. We're just PowerPoint projecting. So we've got 10 watts to the screenish, and we've got 10 watts to the processor unit. So this will take about 20 watts. So 30 watts when it's working hard, 20 watts when it's sitting like this. Put this into idle mode and it'll be less than 1 watt, something like that. So you know, you can monitor it, and then you can put in the hours of operation under the different statuses. Yeah, so if you work out how many people are leaving their computers idle for how many hours, and you can get therefore a much more accurate picture of what you're using. So two ways of doing that. The audit is pretty comprehensive, covering all types of equipment within the office. So it encourages you to bring everything in, right down to your telephones, etc., and bring in your whole carbon footprint there. And to do the audit, clearly one way of doing it is to walk around the buildings. I quite like walking around buildings because you see an awful lot of bad practices and you really get a feel. And you get a feel for equipment, water coolers, fans left on, the old supplementary heater, lights that shouldn't be on. You get the whole thing. So I would recommend doing that. How else could you do an audit of your ICT equipment? How else could you do that rather than walking around? ask your IT department. You can actually communicate with them. Yeah, they're good to talk to. Yeah, so you've got a language barrier on the IT information. Of course, you've got a language barrier, and trying to get across that all the technical speak that they speak. But yeah, absolutely, talk to the IT department. They will, from their network server, they will be able to give you all the addressable points of all the equipment that there's operating. And so do get in dialogue with them. Certainly increasingly I'm finding IT departments do want to talk to people, and in fact they've got some very important messages that they need to get out to people in terms of how to run their computer equipment, to stop viruses, stop infections, and manage the system and make it resilient. So there's a two-way thing here, but there is a big language barrier with technical information. So talking to them as an energy manager about these things is really important, and we'll talk about that further. So that's a... Yeah.
It's interesting, last week when we spoke to Conwy Council about this, and they could even tell if the equipment was idle or whether it was on from the addressable points.
Yeah,
it's a very quick way of doing it.
Yeah, so it's a really good point. So the IT manager there could actually not only give you all the addressable points, but from his network server hub, he could look at exactly what's running at any point in time and could give you a full schedule of what was left on and what the status of it was. So some really powerful information can be got from the IT guys. So again, talk to them and get that communication. Thank you for that. Some of the rules of thumb that came out from the SUST IT surveys and tools: one computer for every 8 to 10 students, one computer per employee for fairly straightforwardly, one laser printer for every 20 students, one laser printer for every 5 employees within a university environment. Again, you've got to question that, haven't you, really? But it gives you some sort of rules of thumb for an audit, and gives you some thinking. I'll add to this as we go through this morning on various other things. And here's an example of using that tool, coming out with a pie chart at the end. This is the University of Sheffield, and their ICT is 18% of their non-residential carbon footprint, so very significant, as you'd expect within a university. Probably about half of that going to PCs, servers, the central servers being about, what, 20%-ish. Your high-performance computing, this is your research computers that are doing lots of iterative calculations, working very hard, about 14%, and we'll talk about the difference there as we go through today. 10% of the ICT goes to printing and photocopying, etc. So it gives you a reasonable footprint and starts to get an understanding of where the energy and the carbon and the costs are, so that you can talk to people about how you can start to reduce this down. So that's a useful tool, and I'd recommend everyone to do that. In terms of delivering practical savings, the first part for every organisation to start on is out-of-hours survey. What is happening to deliver savings? By simply switching off. That's the key to this, really. The reality is, and Carbon Trust posters have said, that the photocopy left on overnight uses enough energy to produce 1,500 copies. So certainly let's use some of these messages to bring staff up on board, and let's get energy managers in place within each of the offices, in each office area, whatever type of organisation you're in, to switch things off at the end of the day. Clearly, switching off is the easiest way to save some energy. Increasingly, and under the Energy Act 2011, the government have said they want smart metering to come in to all supplies, and it'll happen over a period of time. What does smart metering do? Smart metering gives you a very good way of looking at the electricity consumption throughout the day. This is the results of an electricity smart meter, and you have 48 half-hour readings from midnight to midnight, giving you the electricity consumption, what is actually consumed. So here you've got it at about 80 kilowatts. That's 80 kilowatts per half hour, or 160 kilowatts left on within the building. And this is the profile of an office. You've got the start-up, full occupancy, and then people at the end of the day going home, and the building completely vacates at about 8 o'clock, and you've got this typical line of, there'd be a few people in the office, but an awful lot of plant and lighting left on at the end of the day, because people aren't switching things off and the kit's left running because people haven't shut off the plant at the rooftop, etc. And that's a sort of typical waste. But the key thing here is, why are we using 160 kilowatts overnight, and on Saturday, and on Sunday, when nobody's there? If you're 60 hours a week in your office, you're 108 hours a week not there. And if you're leaving this sort of quantity of energy on for the 108 hours a week, clearly it's a huge amount of waste. And it's not uncommon for organisations to use 30–40% of their electricity when the building's locked up, because they're leaving things on. So it can make a very big impact, and you can get everyone working on this quite straightforwardly. First thing to do on this is to look at whether you can get AMR, whether you can get the half-hour smart metering data, this sort of data I've just shown you. And the first thing to do is to look at your electricity bill and look at the MPAN, meter point administration number. It's on every single electricity bill, and it looks something like this. And the important profile class is the first 2 digits. And if you're 00, that means your site is a large site, it uses over 100 kilowatts, and you should be able to get this from web access. And so you should do that. Most people have done that now. It's there. Talk to your energy supplier. Over the last 5 years, finishing in 2014, every single smaller site with MPAN numbers 05, 6, 7 and 8, that's the monthly supplies, using over about £8,000 of electricity a year, should have had smart meters fitted. If you haven't had them fitted, you should ask them to be fitted, and they will get on with it straight away. Yeah, because it's ending in a year or so's time. If you talk to your supplier, they will do this free of charge. They will fit the meter because the government has told them to. If you've got 05, 06, 07 and 08s, again, you can then get those fitted. There will be a charge to get the monitoring data, perhaps £10 to £15 a month, to get on a website access to get that half-hour data. Yeah, but it's very, very powerful. If you decide to run a switch-off campaign in here and we start to switch off a lot of equipment, I know the Carbon Trust have already switched off a lot of equipment here this morning because they've had a lot of things running. If you do switch off the equipment, and we do it today here, and we get everybody in this building to do that, we can tell them in 24 hours' time, it'll download overnight at midnight, we'll be able to show them the graphs and show them the impact they've had in this building because they switch things off. So it's very fast response. Within a week, you can actually get staff motivated to do something about this. If you're a smaller business, and the smaller business is the small quarterly supplies, this number will be 03 or 04. If you are a quarterly supply, as an SME, I know a few of you are SMEs, then you can get smart metering. And under the Energy Act 2011, the government has said to the electricity industry, they want smart metering to all commercial supplies, yeah, in a period from 2014 through to 2018. So it's on its way. On the basis it's on its way, when you next go to tender your electricity, ask the supplier to put in a smart meter for you free of charge. Again, they will do that for you. They will bring that forward. And I'm already doing that with many quarterly suppliers at the moment. They are advancing this early installation. So please get hold of that smart metering data. If you haven't got a smart meter and you want to do it simply, or you want to break up your electricity to different floors, and you want to put an energy manager in charge of each floor, you can use the domestic pseudo-smart meters. These are simple little meters that display the wattage that comes through a distribution board. So we can put it on the distribution board here, and we can display the energy be consumed within this particular floor, or how the distribution board's laid out. Very useful, goes on a desk. Takes about 10 minutes to fit this. You may have to take the cover off a distribution board to fit it around the live cables. But the cost of this is about £50 to fit. That's all, to actually buy one of these, and you then have to fit it. If you can get to the live cables, it is something that anyone can fit. You don't have to be. If you've got the live cables going into the distribution board or onto your meter at home, you clip it around the live cables. You don't actually have to get an electrician involved. These are limited. They'll generally go up to about 100 amps 3-phase. So you can buy 3-phase ones of these which have 3 CTs which you just clip around, and they go up to 100 amps. That's about 70 kilowatts, something of that order. 70 kilowatts will go through this. And what they do is they increase the visibility of the electricity consumption within your floor. So a fantastic thing to do, people can look. And as people are walking out, they can look at this, and they know from experience, they've all tried to switch everything off, they know that this should be down at 864 watts. And if, as you walk out, this is at 2,864 watts, somebody's left a 2 kilowatt heater on somewhere, and you can switch it off before you leave. It's as simple as that. So everyone can act on this. And if someone says, well, should we switch the lights off in here because the sun's out? No, it's not worth doing. You can switch the lights off, and within 10 seconds, this will start to respond, and it will drop down by the load. And you can say, yeah, it is worth doing. Look, it's reduced that load. It's very simple, very pragmatic, and really useful in schools as well. Used them a lot in schools and worked very well. What I would recommend before you launch any campaign to staff is to go out and work with your IT manager and do a survey of all of the equipment. So I walk around a building like this with a clipboard, and I mark my clipboard up with a cross, a question mark, and a tick. It's as simple as that. And I walk around and I record all of the equipment that I can switch off. And I would switch it off as I go around. Everything on standby, everything, switch it off, record it, and estimate the wattage that it may be. I mark up anything that I can't switch off. Fridges, freezers, security systems, whatever it is. These things cannot be switched off, and I can't, so I record what can't be switched off and what the wattages are. And then in the center here I have a question mark. These are things I'd like to switch off, but I'm not sure. I need to talk to somebody. Yeah, so it might be security lighting, shouldn't be running all night, but I'd like to talk to somebody. It might be ICT equipment that I'm not sure about. Is that a specialist computer that nobody wants to switch off at a particular point in time? So I would mark it up and then have those discussions. So relatively simple thing to do. Having done that, you can start to quantify. By switching this equipment off, you've got some savings already in the bag. Then you can discuss things with the IT manager. Can we switch these things off? And I think it's important then to take that to your IT manager to establish policies. Yeah, because your IT manager needs to understand the costs and the quantity of financial loss, the carbon footprint, the CRC carbon tax savings that you may get. He needs to understand all of that and why you're asking these questions. And then he needs to come up with the policies that can go out to staff. A lot of staff believe that you can't touch the IT. And is it familiar that the IT staff say, well, we can't switch anything off because the IT manager wants everything running because we want to download at night. Yeah, and so we can't switch things off. This is very, very common. Whether that's a true perception or whether that's correct is another question. And so you need your IT manager involved to say, well, can we switch things off? Can we do something about this? So again, it's working with them, and the IT manager creates those policies that can go out to save energy. Having got that position, you know the sort of savings that can be saved within your building. You know what the value at stake is. You know that you are talking about perhaps thousands or tens of thousands of pounds by switching things off. It's worth doing that. You could then look with a position of success where your IT manager yourselves can, as an energy or carbon manager, sustainability manager, can say, well, this is worth going at, let's go for those savings. And then you're at a point where you can launch a campaign knowing that it will be successful and knowing that your AMR results, if your staff get involved, will prove the savings very quickly. So you can distribute success and gain enthusiasm and be a successful department which people will want to buy into and be part of. That's quite important. There will be issues though before you launch. What are the myths out there? What is the policy? Can we label up all of our equipment? Our laptop here with a green sticker means anyone can switch it off. Our projector there with a green sticker, anyone can switch it off. Our network server hub on our fridge will have a red sticker, meaning no one can switch it off. We want everybody in the building to be able to know they can switch things off because they've got green stickers. And equally, we know there are a few things that will have red stickers and no one can touch. That means that the cleaner who's coming in, the security guard that's coming around, anyone who's in the building, who's in a meeting room, having a meeting with you, as they leave, they can see that they can switch that thing off because it's got a green sticker on. There is going to be no comeback because that's what's been agreed. So it's a very active, proactive campaign here. It's not just switch off, it's switch off with a bit of thought, and that makes a big difference to engaging with people. Link it to any campaigns, switch off fortnight, certainly there are certain times when the press go around photographing all the government offices, showing all the lights on, isn't there? Try to link it to one of those weeks, try and make a higher profile as you launch it. So think carefully about that. Involve everybody, all the stakeholders. Monitor, use that AMR to monitor the savings. Modern day people are not into, yes, we're going to save something in 2 years' time. We want fast payback to gain that success and enthusiasm. People like rewards and gratification pretty quickly. So design that so it can happen within a few weeks and feed it back to all the stakeholders. Regular checks. How are you going to maintain this? Not only are you going to monitor it on the AMR, of course, but how are you going to get regular checks? Cleaning staff, security guards. Some people have got the last person out of an office area or switch everything off. Well, I don't like that, last to leave. I think the last to leave is probably working harder than anyone else, isn't he? And he's probably the last to leave, and the last thing he wants to do is go around everyone's computer and try to switch it off because they haven't bothered. That's not the right answer, is it? I don't like those. I've talked to, in schools, I've talked to premises managers, and they spend an hour going around switching everything off, rather than the teachers doing it when they leave the building. That's just not going to work, is it? It's not fair, and it's not going to work. So I don't particularly like the last to leave culture, but it is there, and it can work. Design things to be easy. Yeah, power sockets on top of the desk so people can touch them and switch things off. Don't ask at the beginning of this, we expect everyone to crawl under their desks to unplug their devices, because it's not going to be successful. People don't like crawling under this. It's not realistic. It isn't practical in most places. We want them to switch off, but we don't necessarily want them to go that next degree. There's a load of things that can be done. We've got to be commensurate with the priorities here in terms of we drive this forward. Lots of incentives have been done. Give some of the savings to charity. Give some of the savings to a local community. I ran a campaign for a 15-storey office block, which was in the financial industry, and whilst I was running that work, it was quite clear that the staff were not happy because the prices of the vending coffee and tea machines had doubled because they'd gone to some super coffee, you know, the ones that taste really nice, and they didn't like that idea, so they weren't very happy about that. So we ran the campaign that if everyone switched everything off, they could get free tea and coffee. And so we linked into something that was pertinent for that organisation at the time, which is quite worthwhile. Many organisations have given out chocolates and sweets. So somebody goes around at the end of the day without telling anyone and leaves chocolates and sweets out to the people that have switched all their equipment off. If they've left their equipment on, then you don't give them sweets, and then people come in and they wonder why they've got a sweet and why no one else has got a sweet. And you do that a few times, and people start to starts to click with people that, you know, maybe I haven't got the sweets because, you know, the computer's been switched off. I get into my office early, so I go and collect all the sweets and have a nice feast for the day. But, you know, that sort of thing is worth doing. This is a campaign within the local authority in sort of carbon management programs where they linked it to football, pertinent today, isn't it? But they linked it to football, giving out yellow cards, warning cards, and then red cards. And if you got a red card after the second warning, you had to buy sweets or buy cakes for your whole department. So again, we're linking sticks with carrots. Yeah, stick for the person that does it, but carrots for everybody else. So we're making a bit of fun of this and getting people involved, which can work well. And this one looked at this, and they said that in this particular local authority, 33% of the PCs were left on. And it says that on the back of the card. Every little bit makes a difference. Every little bit makes a difference. Some of the myths out there. Logging off is the same as switching off. If you log off, your computer still runs, doesn't it? You're just logging off from the network. Yeah, so not the same. Screensavers save energy. They don't. They access the disk, and active screensavers use more energy than if they're not installed. IT equipment is insignificant. Well, it isn't. Photocopiers should be left on all the time. That's often coming from maintenance companies. No, they shouldn't. They take a lot of energy on standby, and eco modes use a phenomenal amount of money. It takes more energy to start up a computer than it does in running. That's total nonsense. It doesn't take any more energy to start a computer up. A computer takes more energy when it's very active. It's fractional as it starts up, as it loads everything up. It takes a little bit for a few seconds, whatever it happens to be, but it is not worth leaving your computer on. Power supplies adapters, we're okay to leave them plugged in because they take no energy. That certainly isn't the case either. So lots of myths there. Any other myths that anyone's come across in driving energy and carbon? Any other thoughts on that?
Server room has to be 18 degrees.
Absolutely. How many people go into the server rooms and they're being chilled, you know, like a cold store in a factory for storing food? Absolutely ridiculous. Very myth. Yeah. Thank you for that. Yeah. Any other thoughts?
We get the kickback in the morning that it takes too long for the PCs to boot.
It takes too long for old PCs perhaps to boot up.
Well,
Yeah.
it's not even old ones. We've been switched over to Windows 7 and it's no better.
How long is it taking? Is it matter of interest?
It depends. Some people's
Yeah. Yeah, so a few minutes. So, you know, do people come in and make a cup of coffee when they come in?
That's what I do.
That's what I do. You know, I mean, if they're that busy that they can't make themselves a cup of coffee, then they've probably got a point. But if they can't, that's what I do. I come in, make myself a cup of coffee, and then by the time I come back, it starts. So I go make another cup of coffee before I get working. You know, the reality is that these are just cultural change things that we need to deal with. Of course, if switching on of computers is a big issue within an organisation, then you should move to central power management, which can of course enable all the computers before everyone walks in, and that could get around that issue, and we'll talk about that a little bit later on. And perhaps another myth that's very strong there is we can't do anything with our IT equipment because the IT department wants it left on continuously. That is a myth. Yeah. Yes. Yeah. Yeah. It's better for them to be off, yeah, and that is a myth. And I think there was some strength in that 20 odd years ago when we used to have the really old Winchester disk drives that, you know, used to be quite a big bit of kit, And in the end of the day, they did start to fail prematurely if you turn them on and off. But I don't think that's the case for modern PCs. And how often do you change your PCs? Probably anyway, every 4 to 5 years, because they build in obsolescence, so we have to change them because they haven't got the capacity. So it probably isn't that significant now. But that's great. Thank you very much for that. That's a good one as well. I shall continue to grow this list of myths then. I shall take those ideas back. And obviously, do design some posters and get some information out, or electronically out to people. Here's an example of a good poster from a government campaign run by the Carbon Trust, so it would be really useful information there. Anybody got experience of running staff awareness campaigns and driving ICT use down? Anyone done that here? Yeah. Any thoughts, anything on that? Yep. Right. Good. Yeah. So again, making use of the red and yellow cards there within a local authority environment, was it? Yeah. You know, making it fun, and even getting that fun up to the senior directors, which is quite good. You know, it shows it can engage with a lot of people. So try to make it fun and make it well.
Can you summarise when somebody's talking over that?
Yeah. Yeah, that's hopefully I shall try and do my best. Got too many things. I can only do one task at a time, so I'm struggling with multitasking, unfortunately. So yeah, absolutely. Thank you. Let's have a look at some of the other key opportunities that you should be aware of. Let's run through a number of them. First of all, quite commonly, people are looking at hot desking, flexible desking. That's got to be a good idea, hasn't it? Yeah, typically reducing the number of places within your office by about 20%. Quite often, it's very successfully done. You know, moving people around makes your office smaller, much more sustainable. People increasingly having tasks to do with objectives and working from home and flexible working all works very well. This encourages people to move away from PCs and clients, in fact, as well, towards simple laptops, notebooks to do our work. And increasingly, people are becoming more flexible, more portable. People like laptops, and this sort of thing is really strongly accepted, and people keep their kit with them. You know, that's without a doubt. And if you've got a laptop and you plug it in at work and you take it home with you, you are switching off. You're definitely switching off, and you're disengaging from the network. So that's got to be a good idea, isn't it? The responsibility is certainly transferred there. People have historically been putting in quite complex docking stations with external monitors, and that may be required for lots and lots of tasks. But I think you have to question that quite strongly. You know, lots of people are working on laptops quite effectively without docking stations, because docking stations have transformers in, you have your large screens, which a typical laptop would be 10 watts, a 22-inch screen will be probably 16.5 watts now for a modern screen. But you know, there is a difference there. So, you know, lots of jobs, you're not a typist, potentially. If you are a typist and you're doing lots of typing work, then clearly you probably want a very good quality keyboard and a good quality screen. But for lots of us, we're doing random small amounts, emails, things like that on the laptop. How much time do we spend typing? Can we question that? Yeah, thank you. Yeah, I mean, a docking station, within the docking station, you have a transformer, and that transformer will take anything up to half a watt. So they are warm, and I'll talk about that later. The docking station does continue to take energy, just like a transformer you know, on the laptop here today. That transformer will stay warm even if it's not plugged in. And so it is worth half a watt. It is worth switching those off. So thank you for that question. That's a good one. If you're upgrading your PCs and investing in new equipment, then things are moving very fast in terms of energy efficiency. But one problem with major procurement rounds is that if you are procuring large volumes of PCs, is that the prices are very, very similar. So from the main suppliers, the prices are very similar. So what tends to happen with the sales force trying to get your business is they try to upgrade what they give you. They give you larger screens, they give you better sound cards, they give you little add-on graphic cards, whatever it happens to be. They're trying to give you more for your money so they can get the business. That's all very nice, but as you increase that spec, you increase the energy consumption. So all of these things that are being pushed at you are things you may not require. So do think very carefully about the specifications you need to do the particular jobs that you're interested in. And again, people are moving towards laptops, notebooks, thin clients, reducing the specifications of what they have when they're buying. Yeah.
Sorry,
No
what
problem.
exactly is a thin client?
I will cover that later. A really good question, which is probably I'm thinking about and everyone else is. What is the thin client? Can I cover that later? Yeah, because I'll come to that and I'll put it in context of what it is. But it is just an access system into your virtualized computers or your computers, much lower wattage than a PC that's got processing capability. But I'll talk about that a little bit later and put it in context. Thank you for that, though. That's great. In terms of monitors, we've had huge improvements. The old cathode ray tube television set, about 100 watts a piece, and we're now getting down to screens, 22-inch screens that are down at 15, 16 watts. So do look at those upgrades. I came across a company only a couple of weeks ago that had hundreds of these still in work. I don't know how amazing that they had them, but hopefully everyone's got rid of every cathode ray tube screen within their business, really. If you have got a screen, check the modern screens and check they've got auto brightness features. It's quite surprising, actually, that auto brightness features, they reduce the brightness and up the contrast, and they look at what the conditions are within the room in terms of the solar gains, and so you can actually see the screen. And I did some testing for some computers, setting the brightness and contrast at 50%. So we're dropping the brightness to 50%. And I compared that to the auto brightness features that were actually engaged within the screen, and the auto brightness features were using less energy than even dropping the brightness to 50% manually. So they do work extremely well. So do just recognise there is a significant issue there. A 10% saving about by engaging with those on the screen. Reduce all the screens in use within your building. And particularly within docking stations, people use docking stations with a laptop, and you see that their laptop screen, which is half of the energy, about 10 watts, is on at the same time as their main monitor. Yep. So if you're using a laptop within a docking station, switch off the screen, get the laptop screen switched off. It adds to that, and get things switched off across the board. This is the myth that came up on power adapters. The government have a buying standard they put out to all of the suppliers now. The supply adapters should use a maximum of half a watt, and in fact most of them are significantly less than that now. So we are concerned about these power adapters that stay warm when you're using your laptops. You can feel them. If you unplug that power adapter from the computer, then that transformer will stay warm, and that's the clue. If something is warm, then we're concerned about it. And just to put it in context, if you unplug your transformer from your mobile phone and leave it plugged in, and it's a bit of a geeky exercise for you to do tonight, and like everyone for homework, go to leave your laptop, your transformer for your telephone plugged in, and just feel it after half an hour. It'll be stone cold. Yeah, very, very efficient. Losses absolutely minimal, and not a concern for us. Not a concern for us. But transformers within workstations and transformers on laptops are a concern. They do stay warm when they're not plugged in. So it's as simple as that. That's the way in which to judge it. If it's warm, if it's got lights on, or if it's got a fan on, we're concerned about it. We should act on those things first. Another little saving here is if you've got your laptop and the battery is fully charged, don't continue to charge and have your transformer engaged. Once your laptop's fully charged, unplug it, use your laptop, run down the batteries and plug it in again. Easier said than done, perhaps, with the working life you've got, and you want it charged up to use on the train on the way back, but these are simple things that can make a difference. Printers and photocopiers have moved a long way again. Photocopiers used to be very, very inefficient, particularly on standby, using almost the same amount in eco mode as they do when they were not in eco mode. But photocopiers print are much faster, multifunctional devices allowing scanning, 20, 30 copies a minute, much, much faster. Huge scope to rationalize. We used to have dot matrix printers, inkjet printers, lasers printers dotted all over our offices. Rationalize those printers to multifunction devices that are much, much faster. Good practice now is to have you know, a photocopier or a printer, 1 for every 20 staff. That's the maximum you should go to, and you know, a lot less than that if you can manage it. So get people walking to the printer and photocopier. It will make them healthy. That's what we're trying to do. It also means you can have a chat, isn't it? It's good to have a chat. You meet people in other departments you don't get the chance to talk to. So it's a good social point as well at the photocopier. Well, you've got to do some work, haven't you? Actually, there really. Get those printers, photocopiers, check the default settings. What are they set up right up? What is the eco mode, sleep mode? How fast does it go in? You've got to get that appropriate. You don't want to make things difficult for people, but you do want it to go off, you know, within reasonable time at night at the end of the day. Also, you've got access codes for how, you know, who's doing the photocopying, how much photocopying they do. That makes a huge difference. People using their access codes, people being able to watch how much is being copied, makes a difference. Restrict access to colour printing, so people should have to get a permission to go colour printing. That makes a huge difference because colour tones are very, very expensive, and there's an awful lot of sideline activity that can happen with a photocopier if you don't restrict access to colour printing. So all of these things make a huge difference. Make sure you switch your photocopier off at the end of the day. All the huge amounts of sustainability issues as well with a photocopier. Let's move increasingly to electronic communications. Not always easy to do, but let's reduce the amount of printing everyone's doing. Double-sided printing. Yeah, reducing your printing to A5, so you get 2 A5 pages or per page, depending on the clarity of what you're trying to print out. Increasingly using grayscale or eco font within the printers. You set it as default to those rather than high-quality printing. Restrict your access to colour. Use of recycled paper. Cartridges. Check all of these things out when you're buying your printers and photocopiers. But there has been some major programs for organisations where they've rationalised and created huge savings. It's not only the savings on energy, is it? It's the saving on the leases and the management and the maintenance of all of these facilities as well. It can make a big difference. What about fax machines? How many of you have got fax machines operating still? Show of hands. Lots, yeah. Majority of people have, really. If we do a survey, you'd find the majority of people have got fax machines operating. What's the need for fax machines? Fax lines, fax service. What's the need for it? You know, probably 5 years ago, fax machines were needed. Yeah. Over the last 5 years, with the modern printers, modern photocopiers, scanning of documents to electronic is very, very easy, and they should be sent to the emails. How many people have sent a fax in the last week? Anyone sent a fax in the last week? Anybody dare to raise their hand? Yeah. I mean, you don't use them. You don't use them. You do not use faxes. Yep. So why are we still using them? We haven't rationalised, have we? We haven't thought about it. The scope for rationalising on fax is huge. Let's just scrap faxes. They're a thing of the past. They are not needed anymore, so scrap them. So if everyone does that, we'll make a big difference. How many faxes are there in the country? Amongst all the businesses and all the public sector? 5 million, maybe? 5 million faxes? How much per year to run a fax? Telephone line, consumables, £200 a year? It's £1 billion a year saving by scrapping our fax lines and going to scanning electronic communication. £1 billion, yeah. So it can make a very big difference. So again, perhaps that says thinking about rationalisation. Let's question things. We've all got them, and you know, the reality is we need to think about rationalising. If you have suppliers, particularly your public sector, if you have suppliers that continue to want to use faxes, then you've got to give them fair warning. You know, you have to, you know, give them, you know, whatever, 3-6 months notice that you're going to close down your fax service and do it. But it's got to be happening. Anyone see a reason why we should keep the faxes? Unless in case I'm missing something. Anyone see a reason why we absolutely need faxes? No?
So there's people need signatures on things?
Yeah, I mean, we can do electronic signatures, can't you? Yeah, you can do, no problems. That's what we do. So I don't see, but you know. So you can scan in a document with a signature on. Is it different? I mean, obviously, if you've got to have a typed, a handwritten signature, you've got to post, haven't you? So interesting. Yeah, I can't. Interesting, but I don't see a reason. So again, I think it's just a throwaway device that's had its day, and we're all clinging to them. And the only people making huge profit is the telephone companies, aren't they? They'll hate me for the Carbon Trust for bringing these sort of things to bear. But let's do something about it. Let's just have a quick reflection on some detailed monitoring that I undertook for a replacement of some IT. It's always useful. And again, sorry you can't see some of these figures, but again, the slides will be distributed. This is the previous equipment that a particular public sector office building had in. And this is their new equipment that went in. And in terms of operational static, the old equipment took 22.4 watts. It now takes 21.5 watts. Processing on the same type of engagement, 36 watts goes to 32 watts. Power save mode that wasn't there before goes automatically to 19 watts. On switch off of the laptop monitor, these are for two laptops actually, switch off the laptop monitor, so when you switch the laptop monitor off, it goes from 19 watts to 12.5 watts, so it shows you the laptop monitor taking about 6 or 7 watts there. In sleep mode, the laptop used to go to about 2 watts, the new laptop goes down to 1.2 watts in sleep mode. The docking station power, that's the transformer within the docking station, 0.75 watts, that's above the government standard of 0.5 watt. The laptop transformer itself used to be 0.35 watts, and the new one is 0.18 watts, so I think halving that. So I think you're getting an idea that things are generally improving within a selection of laptops. The old monitor used about 20 watts, this is the large monitor, external monitor used about 20 watts. The new monitor, 16.25 watts, it's a 22-inch, large 22-inch screen. On 100% brightness, that went up to 24 watts. On 50% brightness, it was 18.5 watts. So the smart mode that looked after the brightness of the monitor was actually more efficient. The monitor on standby, 0.15 watts. So these things all add up, 0.15 instead of nearly half a watt. So when you've got 1,000 people in an office building, these little things can make a big difference. So anybody done detailed monitoring like this on their equipment? Anybody done that? No? So it's quite worth getting a good electrical meter in and just checking out what's happening and doing that detail. Can be quite useful. Talking about schools and going back to the points that have been made earlier, whiteboards came in, what, 15 years ago, something like that? And I had a head teacher who rang me up because their electricity consumption had gone up by so much when they put them in. I mean, they couldn't believe their electricity consumption in their primary school, single entry primary school, had gone up by 20% because they put whiteboards in. Not greatly surprising. You know, you've got probably perhaps maximum of half a kilowatt of lighting in a school classroom, and you plonk in 200 watts of, you know, whiteboard equipment, so it's going to go up by a third. That's the reality. But your projector here, this is some detailed monitoring. Projector nearly 200 watts. The whiteboard and speakers taking about 15 watts. The laptop plugged into that 28 watts gives you nearly a quarter of a kilowatt, 242 watts. And as shut down in standby mode at night, unplugging the laptop, but all the rest in standby mode, 21.3 watts. So, you know, even in standby mode, the standby projector with the little light on and the speakers powered up in standby mode, and the board takes a small amount of energy there. So again, some detailed monitoring sends out some messages there. Okay. Windows and power save modes. I mean, Windows has again been upgraded, and you know, the switch-off facilities now are even better in the modern Windows. As you move to that, you'll find it even better. But actually, we're not using the basic Energy Star Windows shutdown on our computers very well at all. You know, setting that up, setting up the standards, making sure the IT department, making sure that everyone understands that PCs will go off after half an hour or 15 minutes of non-activity is important and can make a big difference. You know, work with your IT departments to do that. People may override that. So if I've got a presentation computer like this, I may want to override it in case I'm not doing anything and it locks out and jams or something like it does. So you have to override some of these facilities at times. But you can get the default settings at the end of the day to always revert back to the standard switch-off settings that you've got within your computers. So all of this is there and enabled within Windows if you want to use it. The problem is, of course, the majority of PCs, laptops don't use these facilities. They just aren't set up. So we need to think about that within our organisations, why that is the case, and move forward with that. Another way of dealing with it that can be very cost effective for any large network is to put in a centralised power management system. Again, your IT department would put that in. They would put that in at your network server hub, and they could then manage the network. It's very, very effective. This gives timed shutdowns and timed startups for anything, which means that at the end of the day, if people aren't logged in, they shut everything down for you. And then they may download something at midnight, in which case they can bring the computers back on automatically, wake them up, download information, switch them all off again, and then if you've got the problem of people coming in wanting their laptops and their PCs on, they can activate all the addressable points and you know, get everything started up, so that people don't even notice that their PCs have gone off overnight. Again, you've got some very strong reporting software that comes from this. The reports on the financial savings, the energy savings, the carbon savings, these are all developed. And basically these are just clever pieces of monitoring software making access of the existing Microsoft Windows facilities. That's all they're doing. That's what they're accessing really. Lots of suppliers, do speak to them. I mean, the three major suppliers here, the 1E Night Watchman, Data Synergy and Veridian, so those, all of them work extremely well. The savings per PC depends on different situations, of course, but about £60 per PC per year. Nearly half a tonne for every of CO2 savings per PC, and typically paybacks in the order of 6 months. That's typically what they get. These are relatively low cost per machine devices. So, you know, again, your IT manager may be interested in moving this type of thing forward.
And there are some free software scripts out there now, like the one Aberystwyth University developed in partnership with GIS.
Yes, yeah. So, yeah, interesting. Yeah, so for trials, I mean, many people many IT departments have, before they've moved to things like this, have used their own proprietary software and developed their own software. So, yeah, again.
A lot of them are open source and are for sharing.
Fantastic. So, talk to the Carbon Trust, get more information if you want to give it a try. That sounds great. Thank you. Here's an example. The University of Liverpool, again, they started with their own management software and developed that themselves. They advanced power management for 6,500 computers, about 10% of their, about 65% of their computers. The other ones are high-density research computers that needed to work overnight. They didn't have great impact here on people. They only turned the computers off when they were logged off. They didn't actually try to shut down after 10 minutes if people weren't operating. So they did that because they didn't want negative experiences and come back from the students. They set up web-based monitoring and reporting, and on the student walk-in computers that sat there idling a lot of the time, no reflection on the students, but sat there idling a lot of the time, they saved up to £70 per year, and found they could, you know, that's 90% savings on the use. And they started out with their own software, and then they've gone now to a commercial product a couple of years ago. This is a graph that they created that shows the change. The green is the active use of computers, and the red is the idling time. And this is how, with the computers being left on, they were being left on at night, and this is a huge amount of consumption and idling that they were doing. They did first of all, they started with the end of day switch off, and of course you've got a huge drop in idling time by doing that. And then this is switching off the computers. This second drop is switching off the computers when people aren't logged in, and of course a lot of people aren't logged in all the time, so you've got, you know, computers sitting there quite a lot of the day without people logged in, and so you can get down to much, much lower hours of running. So a very, very successful project there. Anyone got experience of putting in power management, automatic power management here today? Any got good experience on that? Yeah. No one's done that yet. Established probably over the last 5 years, these technologies have been there. So do talk to some of those suppliers. If you've got a network with 50 computers on it, it's certainly worth starting to think about doing that. Let's just talk finally about some of the sort of technical opportunities, virtualization and thin client computers, for example. Let's just talk about one or two things there. Virtualization is a great response from the computer industry to make greater use of our computer assets. I suppose if you went back 10 years ago, people who are running IT departments would have been boasting about the size of their IT department, how many megabytes and all of the rest of it that they talk about. The larger, the better, and it was about a status if you had a larger data center than somebody else. Now, there's been a huge reversion, and they are very, very interested in reducing the amount of equipment, engaging with this low-carbon agenda. There is always this push for modern computers to grow exponentially, to everything to get larger. But in point of fact, most of the things that we do, whether it be Word, whether it be Excel, whether it be PowerPoint, is not that hungry in terms of the computer processing requirements. And so the computers that are increasingly capable of doing work are actually sitting there a lot of the time idling. The average computer is less than 5% utilised if it hasn't been virtualised. So 1 to 5% is pretty typical in active use during the day. It's that underutilised. So what we do with that is virtualisation is taking that computer and putting multiple operating systems on it, so that one computer actually becomes 8, 16, 20 computers. So we're running that, and now instead of running it at 1, 2, 3% of the CPU processor unit capacity, we're actually bringing that up at maximum loads up to about 50%. So we're still not challenging it. You know, we've still got a lot of capacity available for any high density tasks that suddenly come. There's lots of calculations to be done on a spreadsheet, but we're running multiple operating systems. And of course what that does, it gets our asset to work for us, and we can have much less assets within our building. So it's much better for the hardware investment, you know, that you actually use a lot less hardware in the long term. The systems tend to be a lot more secure and resilient and don't break down so much, because the software and the operating system could be held centrally. Improves data storage, security, reliability, huge reductions in energy consumption, because you know, one machine, if a network server or a PCU is not operating at 100%, it still consumes the majority of the energy. The energy it moves a little bit, but actually a major proportion of it is just because it's plugged in and operating. Yeah, it can move by 30, 40%, but actually 50, 60% is there anyway. So dropping the number of units we're operating delivers us the savings. And of course, if we combine this with thin client technology, then we move a lot of the processing into the computer rooms and out of the offices. That makes places warmer, and I'll link that up with thin clients in a second. So what we're doing there is we've typically got a huge server room, 1,000 servers on 200 racks, 5 servers per rack, and what we're now doing is we're putting on each individual server, we're putting multiple operating systems, perhaps 20 operating systems per server, so each server is now the equivalent of 20 of these boxes. And so we're substantially reducing the size of our computer rooms, or reducing the density of heat gain by putting less in the racks, and that's the clue here, and that can lead on to savings that we'll talk about later on today. Virtualization is great for general applications. If you're in a university environment and you're doing lots of processing, then high density tasks can be slowed down. But certainly for the majority of offices, there is no problem in virtualizing. And example here is Sheffield Hallam University, 170 machines virtualized, 50% of their estate, saving 90% of the energy to those, saving £43,000 a year. So, you know, very, very straightforward example of what can be done. And finally, if you are virtualizing, then you've got huge capacity available within your data hub to actually do the work. And then the next thought process is, well, why not go for thin clients? What are thin clients? Well, they're just devices for sending and retrieving information. So we're taking out all the logic and all the intelligence out of our PCs that sit on the floor and putting in a small thin client device, typically taking in the order of 10 watts, something like that. That's all they take. And you link that to your keyboard and your screen, and that's all you have on your desk. So much, much less energy being used within the building. The thin client then communicates with your network server hub, where all of the intelligence, all of the applications go on, all of the data storage, all of your work is stored at the network server hub rather than in the thin client. This means that the computer managers can manage that in much better ways. It's much more resilient, it's much more protected as well. So lots of benefits from doing that. And of course, because you're moving your heat gains from your kit out of the offices, again, it hugely helps with reducing air conditioning and making our offices more comfortable in the summer. Thin clients are simple devices, really, and because they're only access systems, they don't tend to go obsolete like PCs as well. So you'll end up upgrading your network servers occasionally, but your thin clients can last a lot longer. Anybody used thin clients? I'll explain what thin clients are. Are you happy with that? Yes. Any thoughts? Yeah. Any thoughts on that? Yeah. Yeah. Very much so. Yeah. So what you've obviously got more data being transferred from the thin clients from where you're sitting, and you're relying on the server hub much more. So the communications have to be right. Yeah. Absolutely. Yeah. Thank you.
I think my first computer worked on British Gas 20 years
Yes.
Spot
Spot on, exactly that, and it's very sort of similar principle. We're going around, as we do, we go around in circles, but you can see the benefits of that. The only issue that can come with thin clients is that if under a disaster situation, if your network server hub goes down, then you've only got a thin client on your desk. So at the moment you've got a PC, and you could carry on working using the PC, and you've got the applications, and you can carry on working, you could save to your PC. Whereas actually you'll all be reliant on the network server hub. So if your network server hub is not resilient, and you haven't got full standbys, you've got problems there, then everyone can end up sitting there unable to process anything. Whereas actually you'd normally be able to work and save later on to the network server hub what you've done that day. Yeah, that's the only downside I can see of that. Yeah. Okay, so moving on. Okay, let's give you an opportunity to share ideas around the table. And what I'd like you to do is, on your table at the front end, if you haven't got one, I'll produce one, should be this little workshop exercise. I'd like just a real good opportunity to share some ideas. And on that, I've asked you to, just in your groups, somebody could just be the scribe, and I'd like just you to come up with some top tips for IT users within your organisation. What are the top tips that you'd like to communicate to them? Just work on that. It's always useful to work on that for a little while and make some notes, take them back with you. So have a look at that. We'll reflect on that after you've done that. Next one is, are there any limitations and barriers that you've come across for staff engagement? Have you found any real blocks? And it's useful to talk about that. You might find somebody around your table has an answer to that. And then finally, are there any interesting, successful strategies that can make a difference? So have a look, and think about that. And we'll share that. Any good ideas we'll share around the room after that. So let me leave you with doing that for a while. Thank you.
Yes, we had one of the members of the table here had got an audit done by Carbon Trust, and I guess that's a plus and a minus in the sense you now know what needs to be done. The limitation is really finding the time to do it, and that seems to be, we're all running businesses and doing things. You can find out these things, it looks like a good idea, but are you able to implement it? And you've got people telling you can't do certain things, back to the comments you made before about maintenance, people say you can't turn this off, and it's a difficult one to do, and we often find these things that you're also trying to run a business at the same time. It's difficult to make these things work. Other things we talked about was local monitoring seemed to be a very good thing, where you can actually show people what's happening. Seemed to be a good one. Time to implement the savings is another issue.
Yes, fantastic. That's great. Anyone else? What about yourselves?
On the limitations and barriers, we actually said that there's a change, the cultural changes, the reluctance of staff to use new technologies can be a bit of a barrier, or is a barrier. And then also the lack of training and education to staff in your employment of those new technologies as well can be a bit of a turn-off. And my colleague here just said about making staff aware of the savings. If people understand what benefits they can realise from making those savings, that's going to reduce the barriers and limitations to the area there as well.
That's great. Yeah, any
tips was turning off computers when not in use. It might be interesting or embarrassing to know how many people have left the computers on this morning. Guilty.
We won't do a show of hands, so you're right.
There's one here anyway.
That is so true.
Three.
Three on that table.
There's only three of us on the table. Enable power management and eco features. I wonder who installs these PCs in the workplace, and whether their motivation is to install it and get running as quick as possible and get away, or whether they've got the time to set it up to optimum settings. Barriers, people don't like external interference, so auto power downs and things when perhaps they haven't saved their work might not be appreciated, so you need to work around that one. You mentioned it, but server room temperatures is a nice easy one, and depending on the age of your servers, you might even get away without having any air conditioning at all in the server room. Or why have a server room if your office is secure? Why don't you just stick the server in the corner of a very large office?
What's your incoming temperature? Your server room?
Well, we're routinely controlling at 25 because our guys are quite understanding, but we're also aware that BT routinely control a 29, so we're not quite there yet, but it's a lot better than the 18 degrees it was when I arrived. So.
Okay. Yeah, that's great. Well, thanks very much for that feedback. I won't hold you anymore. Let's have a coffee and tea break. But I think getting that staff awareness, getting the buy-in, getting the communication is key. The communication is coming out in all of these things, and lots of things are not that difficult to do, are they? But it's just a matter of persevering. And I think the hardest thing is to find the time. And I think perhaps in your action plans at the end of the day, how are we going to find the time? We've talked about lots of ideas. Hopefully there's ideas for everyone to take back. But who's going to do it? And how are we going to find time? How are we going to make that time? That is a big issue, isn't it? It is a big issue. So I'll leave you to think about that over coffee and tea and come back with a solution. So let's have a 15-minute break. Thank you very much. If anyone has any questions from those people that are looking in, then please send them through to us, and we'll try and incorporate them at the end. What we want to do now for the second part, next half hour or so, is look at data centres, or it might be for you computer rooms within your organisation, or it might be network management. So all of those things really mean the same thing. And the reality is there's growth in data centres. Yeah, huge growth in terms of storing data and materials. It's becoming increasingly a large part of the carbon footprint across the globe. This is driven by cloud computing. A lot of us are storing huge amounts of data, backup information, personal photographs, all the rest of it is being backed up in large data centers. Virtualization, again, virtualization is going to mean that a lot more within clients, a lot more data is going to be stored centrally. A lot of applications, usage, business information will all be stored centrally, so our data centers are tending to grow. And that is supported by Moore's law that says processor capacity will double every 2 years, and that's held true for the last 30 or 40 years and will continue to hold true for the next 10 as projected by the industry. So things are moving, data centers are moving forward. What percentage of the world carbon footprint is data centers? Well, we think about steel plants being a huge consumer. We think about our airlines and the obvious pollution from our aircraft. Well, steel is 0.8%. 0.8% of the carbon footprint. Airlines 0.6%, but data centers are significant now at 0.2%. So it is a very, very big industry and very intensive from the energy point of view. And data centers are expanding at about 11% a year. So it will grow, and it will be increasingly an important issue, projected at 340 million tonnes of carbon dioxide emissions by 2020, so it is a big issue. In terms of assessing your data rooms and network servers, how to do that? Well, the industry's way of doing this is to look at power usage effectiveness, and the power usage effectiveness is, if you have a data center, you measure the total power that's coming into that data center. That's the IT power and all of the peripheral support activities. That might be your UPS battery storage, it'll be the lighting, the cooling on the roof, the fans to move the air about, pumps to move the water about, humidity control systems that might be there, any staff facilities associated with the data center, all of those things. And so you've got the total power. And the power usage utilization effectiveness is PUE is the data center power, the total power in divided by the IT power. And so we're trying to get a ratio there. This demands some monitoring, and here's an example of some metering that's gone in on a data center. Monitoring the main incomer. It might also do other parts of the building, so not necessarily that relevant. But then you've got your IT equipment here, is your main supply. You may have IT equipment fed via your UPS as well, so essential and less essential there. And you're monitoring that total IT load, and you're comparing that against the total power, which is the cooling that may be on the roof, so you may be monitoring on the roof, and your power that is coming into your data center. And so your PUE is the total divided by the specific that's going to your IT kit. In terms of looking at power usage effectiveness, it's worth you looking at this for your data center, putting some monitoring in. Historically, and legacy kit, we often find typically 2.5 to 3. So, in other words, 2.5 times the IT power. The coefficient of performance on a standard refrigeration kit is about 1 to 3. So you'd expect 1, yeah, with the COP of refrigeration to go to about 1.3, 1.4. But in addition to that, you've got all the fan power, the motive power that's associated with moving the air, moving the water around. You've got all the lighting heat gains, you've got all of the ancillaries that come into that computer center. So that's typically up at about 2.5 to 3. Modern data centers are definitely moving to less than 2 as standard, and the best practice with free cooling is getting down to 1.2, 1.5. So at 1.2, it's clearly not refrigerated, it's using a lot of free cooling, and so you're only 20% more than the power to the actual IT equipment. So that's the direction it's going. How many of you have got monitoring on your data centers at the moment, or your network server hubs? How many of you can pull that out from the rest of your building's usage? Quite nobody. I mean, it's quite a common problem. In doing surveys of buildings, people don't realise how much power is going to the network server hubs and the computer rooms. It's not that difficult to do. I mean, the cost of putting in a sub-meter is perhaps £500, so it only takes perhaps a couple of sub-meters. In particular, you'll have to sub-meter the power to the data centre, and you may have to sub-meter the refrigeration plant, the air handling units that may be on the roof or elsewhere. So you've got to bring those two elements in, but it isn't that difficult to bring in these sub-meters. Obviously, for those of you in public sector, then you can then, having metered it, you can pull it out of your display energy certificate for the building. If you have a data center that supplies the data performance of a large organization, hospital trust, a local authority, then your decks include the data center, unless you sub-meter it. If you sub-meter it, you can pull it out of your display energy certificate. So that's certainly worth doing. In terms of other things people are monitoring, they are monitoring the temperatures and the humidities within the building. And we'll talk a little bit further about that, and it's worth doing that. So do think about putting in those sub-meters. Having metered it, and if you put on AMR, then your IT manager can look at how much electricity they're using, what their carbon footprint is, what the cost of that is, and you're likely then to be able to pass that responsibility on to them. You may have a target for reducing your carbon emissions. You may be, have a target of 2% a year, 3% a year, whatever it happens to be. You can pass that on to your IT manager, and he can now work with you to achieve that. It transfers that responsibility. So it's certainly worth thinking about, and it is amazing how poor the sub-metering is. When you think it uses perhaps 15, 20% of your electrical consumption, and actually is quite an easy thing to install. Perhaps looking at your operational standards, and this came up a little bit earlier, what temperature and what humidity do we need for our data centers and our network server rooms? Code of conduct for data centers, the EU Code of Conduct, worth looking at that, but perhaps the Americans are ahead on this. The ASHRAE environmental guidelines for datacom equipment are excellent, and that's where some of these guidelines come from. Importantly, is to get an understanding here. What are we talking about? If you've got a network server and we want to keep it in a controlled temperature, we are not concerned about anything else than the air inlet temperature. So you've got a box where the transistors may get to 70, 80 degrees centigrade, and what we need to cool that is stable air on temperature. That's the cold air going onto the unit. At the back of the unit, the air will be thrown out, and that is waste or useful heat, whatever way you want to look at it. That is not of interest to us at all. That might be up at 30 degrees centigrade because of heat gain. That's absolutely fine. It's gone through the system. What we need is stable on temperature. And so, really important, we're talking about air inlet conditions, and that is something that perhaps is quite confusing, and IT managers often don't fully understand and perceive. So that thought process is quite important to talk to them. What are we talking about? Well, the ASHRAE standards are saying that the lowest we should go to prevent any problems with dew point is 18 degrees centigrade. So we don't want air less than 18 degrees centigrade. So not colder than that. In many computer rooms that I go into, they're set to minimum. A minimum on direct expansion chilling is often 16 degrees centigrade. So you actually could cause harm to your computers at that level. The maximum temperatures for most equipment is 27 degrees centigrade. So you can push the temperature up as high as 27, stable on temperature, and the majority of computer systems will be fine with that. So again, that perhaps supports what you're doing there. You've gone from 18 to 25, which is fantastic. Huge amounts of savings by doing that. So we must try to get the IT staff who like to be in a chilled environment for personal reasons sometimes to realise that actually we are talking about 25, 26 degrees centigrade. It's quite correct for a computer centre. Humidity on ASHRAE standards, low humidity down at 40%, the highest level of humidity at 60% for a major data centre where we want to control humidity. In terms of in practice, and I think the point's already been raised actually, the majority, lots of network server hubs sit in small businesses on the floor of offices, quite happily trundling away without temperature control, without humidity control, and without any failures. So you don't necessarily need to air condition at all. When you need to air condition is where you rack these up, when you stick a number of servers on top of each other, each generating a few hundred watts, and you start to become an electrical heater because you're generating kilowatts in a rack. You put kilowatts in a cabinet, it's going to get very warm and damage your kit. So that's why we have to sometimes air condition our data centers because of that rack. So in general principle, in terms of practice, talk to your IT managers about changing the air conditioning settings if you've got air conditioning to at least 24, above 24 definitely, and pushing up to 26 degrees centigrade is where best practice is, and there shouldn't be any problems with kit in doing that. Again, let them just slowly pull it up. But that is the air on temperature to the computer equipment. Despite the fact that that will cause it to be 30 degrees centigrade or above at the back of the equipment is of no relevance to that equipment. It's the air on temperature. But often they get confused. They turn the temperature up, they say, gosh, it's really hot over here, it's 30 degrees centigrade, we've got a problem. They haven't. That's the outlet temperature. Humidity is an issue that you can have problems with. High humidity, if you've got high humidity, then the moisture in the air can cause tracking within the transistors and therefore cause failure. So if you've got very high humidity, you can have failures. Doesn't often happen, very rare happens. The time for high humidity is when we're in the summer and it's pouring with rain outside. You've got hot, humid air that you're bringing into a computer room. If you've got fresh air coming into the computer room, we'll talk about this a bit later, if you've got fresh air coming into the computer room that's moisture laden and hot, it may start to cause humidity precipitation on cold bits of metal, and that then causes problems. So most places are not controlling humidity now, and the majority are uncontrollable humidity, but just be aware of that problem. On the other end of the scale, very low humidity can cause electrostatic discharge, and again that can damage your chips. So the time for low relative humidity is when it's freezing cold outside. When we're sub-zero, the air is cold and has no moisture in it. It's dropped out onto the floor as ice and precipitated. So when you've got dry, cold air outside in the depths of the winter coming in, it's going to be very, very dry into a warmer environment, and therefore you're going to have problems with electrostatic discharge. So at certain times of the year, to be aware if you are finding problems on your computer systems, could it be caused by humidity issues? Why is the temperature of the computer room so important? Well, it's important. Obviously, if we increase the temperature in our computer room, we drop the heat load for cooling. So directly, you're going to lose more heat out of that building to other places in the building through conduction, infiltration, etc. Another reason for it is you improve the refrigeration plant efficiency. If you have got refrigeration plant controlling the cooling of your computer room, as you increase the temperature inside, the temperature in the building is closer to that of the condenser, from condenser to evaporator, and therefore you improve what's called the coefficient of performance. And I'll talk about that in a little while as well. As you raise the temperature of the room, the difference in temperature between the evaporator, the cooling point on your refrigeration, and the air becomes greater. That again improves the heat transfer efficiency, or we can float the temperature on the evaporator, but it improves the heat transfer efficiency, and therefore again you'll get efficiency gains there. And the other thing to do is, as you increase the temperature from perhaps 18 up to 24, 26 degrees centigrade, you vastly increase the opportunity to use free cooling from the fresh air outside, because we now have a much warmer room, and therefore the fresh air can do natural cooling rather than have to engage with refrigeration. And that's a very big opportunity as you start to float these things up. And again, in terms of humidity relaxation that most people have already done, it obviously increases the use of free cooling as well. In terms of the power demand within a computer centre, the individual electrical consumption of network servers is often around 100 to 200 watts. That's a standard amount. More recently, over the last sort of 10 years, sort of the high-performance blade servers, the capacity in terms of generating heat can be much higher, up to 2 kilowatts per unit, something like that. And I think it's quite useful to have a look at what your rack densities are. So here again, you should be working with your IT staff, looking at the racks and what density of equipment we've got. What is the wattage of this equipment? And if you can keep the wattage per rack low density, then you can often do a lot more free cooling. If you've got very high density racks generating a lot of heat, perhaps for research computers, large number of servers racked up here, then you're going to have to move to active refrigeration. And so again, really important to look at how many pieces of kit and what the rating of those bits of kit per rack. If you spread it out more, you're likely to be able to do with a lot more free cooling. This enables us then to look at the low carbon solutions that I'll talk about a little bit further. Sometimes you find that you have some high rack problems, the high density racks, and in that case you could look at segregating them. So here you've got an example where they put in high density racks, they've chilled this cabinet enclosure, and this is for the high density computing, whereas the rest of the computing is much at lower density, and they can do it with much more free cooling strategies. So partitioning things up, looking at things can be useful. Our IT facilities need to plan what they're putting in. What we want is uniform distribution so that the cold air and the hot aisles can work well, and that's what we should be thinking about. And these things are probably fairly new in terms of thinking about this, so try to introduce that in terms of what you're doing. Let's have a look at containment and airflow. I mean, this is a really important concept and probably often not fully understood, because IT managers are not building services engineers. They don't understand what actually is happening with regard to the heating and ventilating and air conditioning of the buildings. From what I've said earlier, what we're talking about here is the on temperature. We're trying for 24 to 26 degrees centigrade, because that then provides the cooling to the kit that's in the cabinet that then rejects the heat. And what we're trying to do here is to get everyone to realise what we want actually is a cold area and a hot area. So the computer room is not air conditioned. It isn't about air conditioning the space. It is about providing a process flow. This is process cooling we're doing here. Yep. So what we are doing is we should be generating our cold air and pushing it into what is a process duct, which is supplying the cold air onto the kit. And if you rack your kit up and you have a definite cold aisle where the cold air comes in, goes through the cabinets, and a definite hot aisle where the hot air gets taken away, the whole thing becomes much more efficient. Cold air is a valuable commodity. We need to contain it, and we need to deliver it to the computers to take the heat away. That's what it's there. It's costing a lot of money to do it, and so we need to contain it. And so you've got this sort of concept where you've got the cold aisle rack and the hot aisle, and you've got that, so each rack faces each other with it on either side, and then things become much more efficient. In practice, some of you will find that when you go into your computer rooms, it'll be a small computer room with a direct expansion cassette in the ceiling, or a wall-mounted unit blowing out cold air. I mean, do recognise what we're trying to do is say, well, let's put our rack sensibly so that the cold air blows down to low level so we get the cold air onto them. The other side will be hot. You don't want to mix them up. You want to make sure that the cold air is going on to the on side. At least the hot air then, at worst, can then escape in the hot area and come back to the unit. But we're trying to make it valuable, that cold air. We can put up portable partitioning we want to try and make more use of that. And perhaps if you've got the ability to return that hot air onto the top of the unit, then that's what you should be trying to do. So there is practical limitations depending on the sort of kit that you may have within your equipment. You may not have the advantage of cold air distribution in the floor and hot air distribution in the ceiling voids. Here's an example of a cold air enclosure. So in order to try and deliver that valuable cold air to the kit, they put up a straightforward, simple plastic enclosure, and the racks are in here, and the cold air is being delivered into this area, and on the other side of the racks is the hot area being taken away. This makes things much more efficient and much more effective in terms of what it's doing. Cold air enclosures are often used. The other way of doing it is to use the main room to transfer the cold air and take the hot air away. There are two ways of containing this. Hot air here, the room is used without very little disruption to the cold air, so the whole room is cooled, which makes it quite a nice environment. The cold air goes on, but the hot air is taken away by enclosing the aisle and taking it away through the roof back into the top of the unit to come out as cold. So simple containment like that can work very well. The hot air will be a larger volume, so you generally not contain the hot air, you contain the cold air, but the advantage of containing the hot air is that if you did want to do anything with regard to heat recovery, and hot air coming off at 30 degrees centigrade is a very useful temperature for space heating. Yeah? So if you did want to do anything with heat recovery, you can heat recover from here. And if you were using fresh air input and output to do your natural ventilation chilling, you could direct this to the building if you could use it usefully for space heating. So containing the hot air has a value there as well. I think it's important to get that understanding of the hot and cold air to people that are managing the computer suite. They may not necessarily have that at the moment. Balancing of the airflows as came up. Where are the airflows going? Because they didn't have that understanding, you may have had a situation where you've got a floor distribution and you've got your diffusers that you can pull up and down and put the air coming into your room in different places. Because people didn't have that understanding, people have probably gone into the room and said, gosh, it's hot over here, standing at the back of a computer rack. And they said, right, well, we better move that diffuser from the cold side into the hot side. Yeah, because it's so hot over here. And of course, they didn't appreciate what they were doing. So very often when we go into computer rooms, the whole thing is being mixed up. And we need to relocate things and redesign it, because everyone's forgotten what it's about in the first place, if they knew in the first place at any time. The other thing is to try and make sure that the airflow is right, and we do this with measuring with anemometers, hot wire anemometers, vane anemometers, to make sure that the airflow is right and going through the computers. Lots of simple things. Yeah, racks often have doors on them. Get rid of those doors. We want the air onto the computer. We don't want any resistance here. If you've got a rack with a number of computers in it, you may have blank spaces. And if those blank spaces, the air will go through the blank spaces. They won't go through the fanned computers so much. So let's just put, for £5, let's just put blanking plates so that all of the cold air that's valuable is forced through the computers. It's there, it's ready to go. Let's seal and draft strip. You seal and draft strip your doors. We're talking about cold air here. It's much more valuable than the heated air in our building. Let's draft strip it and make sure that it doesn't bypass the computers. Yeah. Let's avoid losses into the floor sometimes. You find that underneath the racks, the floor void is open and they haven't sealed it up and you get those losses. All of these things are valuable. Cable management, make sure that the cables are neatly tidied away, tidied together and bunched together. They're not just left like spaghetti in the floors to stop the airflow that's coming through. All simple things that you could act on tomorrow. Your IT manager will love you, won't they, when you go back to all these ideas tomorrow, but hit them with this. Yeah, here's some examples of spaghetti outside, spaghetti, and racks of kit without blanking plates put in on them. So just have a look around, do all the sensible things that are there to let the airflow come through. Look at reducing the heat gains as much as you can into that room, because obviously you've got to chill everything on that heat gain. So the building structure should prevent heat gains. There shouldn't be windows in your computer centre. If there are, then buy some foam insulation with silver backing on it, the standard from Kingspan or Celotex, and just put them in, just push it, just cut it to shape roughly and push it in the window. Stop that solar gain to the building. Look at sources of infiltration. Make sure the doors are sealed. Make sure the structure's sealed. The biggest thing is suspended ceilings, which are standard within our computer rooms. Where the cables come down from that suspended ceiling, often people have taken the tiles out. The tiles are half broken. Is that quite common? I find it all over the time. We need to seal those suspended ceilings up as much as possible. So where your cables go through the ceiling, make sure the ceiling tiles are continuous and well in use. Otherwise, you're just air conditioning the whole of the ceiling void sometimes. Minimise your fresh air. There'll probably be a small amount of fresh air coming in for occupants, probably fresh air from outside. Minimise that as much as possible. Switch off the lighting. Make sure there's lighting control so that people aren't there, the lighting goes off, and make sure it goes down to a minimum level. People need quite high lighting levels when they are doing work on the IT equipment. When they're putting all the cabling in, they're looking at little numbers and little grommets on the wires and making sure they plug them in right. They will need quite high lighting levels for that detailed work. So perhaps high lighting levels when they're working actively in there, a very appropriate lower level of lighting, perhaps to 150 lux, That's perhaps you know, a quarter of what you normally have for that computer room when it's just general occupancy, and get it switched off when people aren't there. Get your batteries, any heat gain that's not necessary, get it out of the air-conditioned environment. Reduce the IT load, switch monitors off as much as possible, decommission, virtualize, all of the things we've spoken about. Try to look at that quite carefully. So lots of opportunities for reducing heat gains. Anyone had any thoughts or any successes on reducing the heat gains to their computer rooms? Anyone done that? Any thoughts? No? Not at all? Nobody gone in there and had a look at that? You know, nothing clever there really, lots of simple pragmatic things that can be done and advance fairly quickly. Ventilation air, typically we design ventilation to these rooms at about 12 litres per second per person, pushing in full fresh air all the time. But of course these areas are not occupied very often. You know, during the night there's nobody there, for example. So do look at how many people it's been designed for, measure the ventilation air and reduce it to as low as possible. This is bringing a heat load in all the time from outside. We can operate this with a variable speed drive from CO2 sensing if it's a large data center, for example. So again, it's a small area, but worth thinking about. In terms of refrigeration loads, what's important here is to just look at temperatures and why do we need cooling? Well, our processes are quite hot. This is a graph that's showing temperatures here against the sort of components of the system. Processes are quite hot, but you're cooling these with a facility air that's, we're recommending 24, 26 degrees centigrade here, something like that is what we're looking at. Sometimes using chilled water. Often that's set down as low as 6 degrees centigrade, but we're trying to push that up as much as possible. That's generated often through a refrigeration system, with the evaporator providing the chilling at a lower temperature than that, and the condenser rejecting the heat out to the environment. And our ambient air is sitting here between, depending on the environment you're in, anything from hottest at 40 degrees centigrade right down to sort of -10. So your typical ambient air during the winter, for example, is probably about 10 to 12 degrees centigrade, and is lower than the temperature of the chilled water you're likely to be operating at, and certainly much lower than facility air. Facility air 24 degrees centigrade, outside air 12 degrees centigrade on average during the winter. So this is more than enough during most of the year to chill and give free cooling. Why we're doing all this refrigeration step is, you know, quite surprising when the outside air can do it. So we need to question that. So that's a big area to look at. And the other area to look at is, if we are doing chilling, then there's a lot of waste heat here. And this sort of temperature of waste heat can be very, very useful. How many of you are using the outside air to chill your systems? And how many are using heat recovery if you've got refrigeration? Probably not many of you. Many of you will be using air to chill your systems because you haven't got any chilling. You've got your network server hub sitting in the corner of an office, and that is doing the same thing. But why do we suddenly have to get so intense with it all, with air conditioning? Because we're stacking these things up in great big racks, and the gains are too high, and we need to air condition them. We need to think about that. It's not a viable solution long term. If you have refrigeration, the basic refrigeration cycle is, you know, the cooling's produced at the evaporator, the condenser rejects the heat, and you have a compressor that compresses the gases here, the cold gases, producing hot gases, and it goes around to evaporate here to produce your cooling. The key thing here is that the difference in temperature between the evaporator and the condenser is what drives what's called the coefficient of performance. So if you have got a refrigeration, we are very concerned about minimizing the temperature between the lowest temperature and the highest temperature at the condenser. That's the key in terms of energy efficiency, for all the reasons we spoke about earlier. So what we're trying to do is increase the temperature of our evaporator as much as possible, and that will be, if we elevate our temperature in the computer room to 24, that will be achieved by increasing that. And we need to drop the temperature of our condenser. So larger condensers, clean condensers, making sure that that is as free to give the cooling to the hot gases as possible and get condensation is the important thing. So this will improve the efficiency of our systems. If you put all of your external compressors and condensers together, they will get hot. That will decrease the efficiency. So if you put them all together in one compound, it's going to get hot. Here's an example where the hot condenser output just blows into the next condenser. So just try and get fresh air to get that hot air away. These are simple things, but can make a very big difference to performance. I'm not going to go greatly into low carbon refrigeration, because I'd like you all to think about trying to avoid refrigeration as much as possible. But if you have got refrigeration, lots of things could be done, converting from direct expansion to water-cooled systems, modular systems, variable speed drive compressors. Lots of high-efficiency packaged units are now available, turbo chillers, etc. Free cooling to the condensers, so that chillers give free cooling is available. So if you are looking at replacing any kit, then look at energy-efficient options when you're doing that. People are moving to cooling water towers, evaporative cooling. I know you have problems with Legionnaires and you need to manage it very, very well, but these towers will be operating under cooling load all the time. People are moving to cooling towers. Cooling towers work very safely across all of the globe. They're used hugely in warmer climates, so they are very safe, but they need to be managed. If you don't like cooling towers, use adiabatic cooling. This is where we put mains cold water onto the metal heat exchangers of a condenser and drip that through, and so you get the evaporative effect on the outside of an indirect system, and you haven't got a trough that can develop bacteria in it and algae, etc. People are using free cooling. Yep, the problem with free cooling is you may have some problems with humidity, so people are directly bringing fresh air through their computer rooms and to the cold aisle and doing it with fresh air from outside and taking the hot air and using it to heat their buildings. That is being used. They may need to filter it as well through a filter, obviously, if you're in a city environment, but that is being used very, very effectively. People are doing it indirectly as well, free cooling through heat exchangers if you've got a problem with pollution from outside, so lots of ways it can be done. There are also liquid pressure amplification, all sorts of technologies to improve the efficiency of your plant if it's there. Typical COPs on refrigeration are typically about 2.5 to 3, but with some free cooling, people are coming out with COPs now for data centers about 6 to 10. Huge improvement in efficiency can be achieved. Here's some examples of public sector funding through the SALIX and some showing the sort of broad range of projects. Here you've got the University of West of England. Traditional direct expansion cassettes in the ceilings. And what they've done here is they've brought a simple fresh air input to replace these. Project cost about less than 20k to do that. And this now operates by bringing in filtered fresh air through their computer rooms. And that works for 70% of the year. During the very hot climate, in the summer, they shut that down and they bring the cassettes back into use. So it's very, very hot, so that's for 30% of the time. And the payback period on that is about 5 years, so effective little program. A little bit more capital investment here. University of Aberdeen replacing chillers, using packaged free cooling chillers. And obviously it's quite a cool environment in Aberdeen up there, a little bit cooler than here, but these machines can give 50 kilowatts of free cooling at about 5 degrees centigrade outside, which allows them to do a lot of free chilling on their servers and moves into that again, coming out with about 5-year paybacks. And finally, perhaps more ambitious, Cambridge University here, doing some simple containment, putting up partitioning to create a cold aisle with a hot aisle on the outside. So simply doing what we spoke about a bit earlier, creating that. And then they've also put in evaporative cooling. So they're using evaporative cooling outside the building, getting rid of refrigeration and using the sun's energy to give us cooling, evaporating water to give us that cooling effect. So some great examples. Again, about a 5-year payback, £40,000 of investment there. So some exemplary projects there to show you what can be done. Perhaps one of the most difficult things is, we can talk about all of these techniques, but some of the things we've just presented here are things that you're going to need to think about quite hard. So if you are reviewing your data center requirements, computing requirements for the long term, get the clients to work closely with your IT managers and your facilities and building services staff. It's only by getting all of these three to work. The client needs to know the implications, the IT manager needs to look at the maximum use of the kit and spread it out amongst the racks, for example, and the facility manager needs to work on how we can do the cooling for the lowest cost and carbon content. It takes time to get right, so don't think this can happen straight away. A lot of projects don't happen because people don't have the time to think about what the best answer is. So do recognise time will need to be built in. In terms of business appraisals, look at the life cycle costing. How much is the energy going to cost to the equipment? Yeah, and look at the annual cost you're going to save by doing projects like this. Question the building form, particularly for low ceiling heights. I go into lots of computer centres where there are very low ceiling heights. They're put in often in the gunnels of a building, right in the cellars or whatever it happens to be. If there's low ceiling height, it's going to need a lot of fan power, and it's going to stop us using free cooling techniques. Also, what is the access to outside? Is there easy access so we can put free cooling plant or refrigeration plant, whatever we're doing, outside? Or is it, particularly bringing inducted air? Can we bring inducted air to it? Very often, computer centres are located in the centre of buildings, and it becomes quite difficult to do. Avoid city centres if you can. If you've got buildings outside city centres, use that as the point for putting in your air conditioning. And oversize things so you can get free cooling. All of these things need to be thought about fairly carefully. So how could we utilise the waste heat coming out of our computer rooms? Really good question, and really interesting. You're saying it's next to a boiler house, which is really interesting. What you've got to realise is that when we're looking at waste heat recovery, we're looking at the grade of heat and the quantity of heat, and the grade of heat is actually the limiting step. So when we've got air coming out of our computer rooms at 30 degrees centigrade, or if we have air coming off the condensers outside rejecting the heat, maybe again at 30, maybe 35 degrees centigrade, that is a really useful, often continuous source of heat energy for us. However, if we try to integrate that with a boiler house, what have we got in our boilers? We've got boilers that are a closed circuit that operate at the boiler temperature. The boiler temperature may be 82 flow, 71 return. That's the standard for low pressure hot water that we all run our domestic houses on and our offices on. We're not going to be able to get any heat recovery from 35 up to 71, 82. It's not there. So the fact it's by the boiler house is not helpful. But what's in the boiler house where we might be able to get some heat recovery at 35? What could we usefully use 35 degrees centigrade energy at in the boiler house? Any thoughts? Hot water. Domestic hot water preheat. Our domestic hot water, our mains cold water comes in at about 5 degrees C. Potentially we could preheat that up to 20 degrees C for use. Not a huge load, of course, but we could do that. More importantly, if we've got warm air, could we push that in through the ceiling voids? Yeah, could we put a damper on it, a control system on it, and when we're heating up our building, or when we need heat in our building, could we push the warm air into the ceiling void at 30 degrees centigrade? If we could we push it in and have it coming through? 30 degrees centigrade is the ideal temperature for heating our buildings. Can we do that? And that's what we'd be thinking about. Space heating is a much lower temperature grade at 20 degrees centigrade in the building. So we'd be trying to do that. So that's the, but it's not easy, but worth thinking about a little bit further. What's important now, I think, is I've thrown a huge amount of ideas at you, and the idea of this was to throw lots of ideas, and hopefully that some of them will click with you, and everyone will go away with something. So in front of you is an action planning document, and the idea of this is just simply that you can record any interesting ideas. You're going to be as busy as anything this afternoon with all the work when you get back, clearly, and you're going to come back to this in a week's time and think, well, what was that thing I was going to do? So this is an opportunity for you to just to make a note of it, really. So, record who you are, what your organisation is, what your energy bill is, and on the basis of 15%, how much do you spend on ICT? Just useful just to write that down. Make your best guesstimate of how much this is actually worth. Then record any issues down that you want to act on, and say, what are you going to do about it? Who are you going to see? How are you going to communicate this when you go back? And who's going to be responsible for this? Is it you, or is it one of your colleagues, or is it a group of you? Just spend the 5 minutes just to make those notes down. The front of the form is, the white one is for you to take away. The yellow form would be really useful for us to take back. The Carbon Trust will have that. If there's any projects in there you want any further Carbon Trust assistance, then we'll know and we'll get your thoughts. So if any Carbon Trust assistance you want, please make a note of it on that yellow form as well. And a lot of sharing of good ideas, so thank you very much for participating in that, and also sharing your ideas with others around your table. I think that's been very valuable. Anything anyone wants to add? Any thoughts that's come up? Anything else you want to add to that? Yep. I think you've all ready for your lunch, etc. Do leave your yellow forms then, because that will record to the Carbon Trust what you're doing, that you have been active from this. If they can help, they will be in touch. Do get the opportunity to talk to the advisors. That's Lee, Lucy and Karen over lunch. They're there to help if they can. Also put your feedback forms on the tables and we'll collect them up afterwards. And I'll hand over, see if there's any questions from the webinar.
Right, I get to be the glamorous assistant here, lifelong ambition. We've got one serious question, another asking whether or not the slides will be available. Yes, they will be available. They'll be available as a download from today. Also, they'll be sent around via an email as well. There'll be a link sent around. The technical question for you, Ed, is from Sean Cullinan, Paul's colleague at Cardiff Met. Like many others, we are looking to continue to eke out the investment we've made into the PC infrastructure of thousands of PCs. Marrying this with virtualization leads to a quandary where we're using old and inefficient PCs to attach to virtualized resources. Is this better or worse than replacing or disposing of old but functioning PCs with new thin client devices? Is there a recognized approach that is more effective? So a few questions there.
Okay, yeah, I mean that probably comes just back to practical project management, I think. If you've got thousands of PCs, to actually change them over to thin clients all at once would be a huge piece of work. I mean, the PCs have a life to them. We should try to make most use of that life. The savings are quite significant. Again, you'd have to look at the PCs that are operating. Your PCs may be operating, taking 50 watts, for example. Your thin client would take 10 watts. So what is the value of that energy financially? And from the carbon point of view, that might be some influence on how quickly you want to do that changeover. But it's actually going to probably be not justify getting rid of very good equipment that's working already. So what the approach would be on a system like that of 1,000 computers is to trial the thin clients and move slowly by departments. It's going to be a huge job moving to thin clients anyway. So you are transferring it over, you need to transfer your operating systems, change the operating systems to your network hub. It's not something that can be done very quickly. So take one department at a time and transfer that over and get that working. That's the right way of doing it. You're phasing your spending on IT kit year on year, every year. You want to be replacing a certain amount of it because the cycle is every 4 years, perhaps you're going to be replacing it. Perhaps a bit less with thin clients, but you are going to be recycling it. So just do it as a managed practice. I think that's the way to do it. If that gives it some answer.
I was just wondering about off-siting. Lots of companies, particularly larger companies, do this. Perhaps go to Iceland, geothermal energy for electricity and free cooling. I'm just wondering, obviously there are CO2 benefits, but are there cost benefits? Obviously these companies are charging for hosting your server. Do they compare with hosting in-house?
I mean, I think it is a big industry, cloud computing, off-siting of your data centers, taking that and giving that responsibility to the private sector to do. Is it something that you should consider? Yes, it is something you should consider. Is it value for money? Well, I think you've got, it will be expensive to do, but in the end of the day, you are transferring a large number of risks to them, and a lot of time and work. I think when you start to look at all the risks you're transferring, there is some very big value in having external parties to do this work for you and saving man time, buildings, costs, capital costs, maintenance costs, etc. So it can be worthwhile. I'm not, it depends where you sit and how you do that analysis, but if you build in the risks, private sector energy services companies doing this type of work can deliver very good work. In terms of data centers and their carbon footprint, a well-managed data center in the right place as we go further north will have more capacity for free cooling. So definitely there is some carbon credentials there that can stack up. I would look at them very carefully because there can be all sorts of claims for these data centers, and I would look at that very, very carefully. And there's no reason why here in rural Wales, where if you put a data centre where you can use fresh air cooling here, there's no reason why you couldn't have a very low carbon data centre using fresh air cooling here, or adiabatic cooling, or evaporative cooling. So, what is the great advantage of going to perhaps Iceland? I don't know. I'm not quite sure of that, but I think you'd have to look at that in a lot of detail as to what they're professing and what you could do yourselves, really. Does that help in some way? I'm sort of skirting around it, but,
Okay, any other questions? Right, I'd like to thank Ed. You've had a lot to contend with today, Ed, so thank you very much. Don't forget to leave your feedback forms, and lunch is served at the back. Plus, I'm being told something here. Ah, sorry, nobody can see me. Thank you all on the webinar as well. Okay, cheers everyone.